Hi, my name is Karthik Ranjan, and I'm responsible for managing ARM's relationship with carriers. So we cover Tier 1 wireless and wireline operators, everybody from China Mobile to Vodafone to AT&T, as well as the likes of Comcast and Liberty Global. The way that ARM works, we're a semiconductor IP company, so we supply the semiconductor industry with various bits of IP, and our role within the carrier relationship team is working with operators in terms of how they can use all the great system on chips which come out using our IP for various applications. And so I'm here today at the TC3 event here in Mountain View, and today I'd like to talk to you about one of the applications which we're demonstrating, which is very interesting for carriers, which is virtualization of set-top box. Now, the interesting thing about virtualization of set-top box is that operators can now roll out new services very easily without having to worry about the complexity of software in the box, whether there's enough processing in the set-top box, because they can leverage the capabilities of their infrastructure within the network and the low latency they have by being very close to the customer premise in order to be able to offer services where all the execution takes place in the cloud and is essentially rendered on the set-top box. So as this is a chalk talk, I'm going to try to use the whiteboard here behind me to explain how this works. So in the client side, you have your TV or your display. And to it, you can have a very small dongle or puck. We were all familiar with the Roku sticks and the pucks, which are widely available now, that are perhaps Wi-Fi connected. And then you have your broadband router. So here we have Wi-Fi. And then here you have your WAN connection, which could be LTE, could be DOCSIS, could be fiber to the home. Let's just take a landline here, and let's say it's DOCSIS, so on a cable network. And then this goes up to the operator network. And what we're showing here is the ability to use ARM-based servers in this kind of environment. Now, the benefit of the kind of SoCs that we've chosen for this application is that we're actually using mobile SoCs to build the server application. Now, the interesting thing about using that is that if you look at the different eras of computing, we've seen how standard desktop silicon has replaced the old architectures in high-performance computing. What this aims to do is borrow from that concept and using off-the-shelf standard mobile silicon. So what's in your mobile phone is now being put into a server, and that's where you're executing your applications. So the way the operator can benefit from that is, for example, if you want to run Android applications, say gaming, for example, but you really don't want to put Android on the box and download games to the box, you can actually execute your Android applications here on the server platform that's based on a mobile silicon. Now, the beauty of that is that you don't have to change the code, you don't have to alter anything, because the same binary on Android that's written for your ARM-based phone is going to run within the cloud. Now, the benefit is that execution happens here, and we're working with a partner of ours called NetZen that's actually building this software on this ARM-based server. And what they've done is actually taken this Android application, and their secret sauce is being able to convert that into a video stream that now gets decoded on the client. So what you have coming in here is H.264 in this instance, and you still have a remote, so your user interface to the box is exactly like you have today. And so the only difference is those clicks in this type of application are, guess what, sent back into the network, rendered here, and then sent back down as an H.264 video stream. So through this mechanism, we see the ability for operators to offer new, innovative, disruptive services. And so we look forward to, please come see us, our demonstration and our stand. Thank you very much.